And I know you have a busy schedule, but you have accepted to animate this this webinar. I congratulate you and salute all the work you are doing. For a long time, I have been following you on LinkedIn, and I see what you are doing about geospatial data and about your sense of sharing knowledge to the communities. And this webinar is an opportunity to connect and to share with people from many countries about Python and geospatial data. My name is Dr. Labaly Toure. I'm a teacher at university in Senegal, and I'm teacher on remote sensing, GIS, and environmental data. And today I'm very happy to organize this webinar with Dr. Qisheng Wu. For your knowledge, I just present who is our animator for today. Dr. Qisheng Wu is an assistant professor in the Department of Geography at the University of Tennessee, Norwich, UTK. His research interests include geographic information science, GIS, remote sensing, and environmental modeling. More specifically, he is interested in applying geospatial big data, machine learning, and cloud computing, example, Google Earth Engine, Microsoft Planetary Computer, to study environmental change, especially surface water and wetland inundation dynamics. Dr. Wu is an advocate of open science and reproducible research. He had developed various open source packages for advanced geospatial analysis. I hear you have a big CV, a big resume, but I don't just be a resume about your presentation. Now I'm going to give you the follow to begin your presentation. Just let me invite the participant, please. I invite you to turn off your microphone and your camera, please. It's for the participant. Dr. Wu, if you are ready, you have the flow to begin your presentation.
Okay, sounds good. Let me share my screen. Can you see it okay?
Yes, give me just 10 seconds. Just I add some participants in the webinar.
Yeah, yes, sounds good.
Yes, you can go.
Okay, good afternoon, everyone. Thank you very much for attending, and thank you, Dr. Toure, for the very kind introduction and invitation. So it's my honor here to talk with you and share some of the things that I have been doing during the past year or two. And so the slides can be accessed by scanning the QR code. I also send the link in the chat. You're welcome to click the link and to follow through. You can always come back if you have questions or you need to look at some of the resources that I share. So for today, I'm going to talk about how to use Python for geospatial analysis and interactive mapping. And so most of this, the work I'm presenting started after the pandemic. Before that, I used to heavily use commercial GIS software packages, and so now I'm kind of transitioned to more like open source and free. And what my goal is to actually create tools and packages that makes it easy for everyone to use, so that even if you don't know a lot of coding, you can still use it to do some interesting geospatial analysis. So,
Dr. Wu, just
yes,
we have more participants who are on the French. Sometimes
go ahead.
I just will have some break to translate for these guys, but not it's not every time. But if you do when okay, it's not necessary, but we can sometimes you can just have a break to translate for the people don't speak English. But I think that more of them understand what you have said. Okay.
Yeah, just let me know when you want me to stop. Yeah, I'm happy to.
Okay.
Yeah, just let me know. Yeah.
Okay, you can go.
So here is the outline. So I'm going to primarily talk about 3 Python packages that I developed. The first one is Geospatial, second one is Gmap, and the third one is Leafmap. And then lastly, I'm going to show you some resources where you can learn more about this. And hopefully we have some questions, time for question and answers. On the right here, shows you an animation, right? There's like a volcano eruption. I think this one occurred earlier this year in January 15, right? It's a huge volcanic eruption. So think about this. If you are asked to create an animation like this, how long does it take you? I mean, using traditional tools, you need to download the imagery, you need to mosaic them, you need to maybe do some pre-processing. It might take you hours actually to create some kind of animation. But now it takes you probably less than 30 seconds and you don't have to do any coding. You don't have to download anything and you can create. So if you're interested in, you can click the link to create those kind of animation. And so I create this web app here. There's a link, so you can click the link and then go to the website. You can create on the right here. I also show you the tutorial how you can do that. So basically, behind the scene, you use the Google Earth Engine cloud computing platform to do all the computation. So all you need just to click a few buttons, specify the parameters, and then you will be able to create pretty much any animation using almost pretty much all the satellite imagery available within the Google Earth Engine data catalog. So just simply draw a rectangle, choose a different band combination, and how many years you want. You can change the color. So there are lots of options you can actually customize, and then just click submit. Within 10-20 seconds, you get this kind of animation pretty easily, right? And then you can download, you can share on social media. So give you a quick way to demonstrate how satellite imagery can be useful to monitoring environmental changes or during the past few decades or something more recently. So try it out if you're interested in how to use it. And so next, here are some examples like you can see what's the differences between 20, 30 years ago and now. So you can see the dramatic changes human have on the environment. So the first one on the left is the drying of the ROC, right? It's almost gone. On the right here is the mining in Canada, right? There are a lot more examples, just quickly go through. And coastal expansion in Dubai. On the right here is the meandering of rivers in Peru. And also, for example, deforestation, landslides also in Peru. So you can see, for example, this landslide lasted for over a decade. You might not be able to see that on the ground because it's very slow. But when you put that on satellite imagery with a longer time span, you can see the dramatic changes of this landslide. Also, urban expansion, for example, Las Vegas in the US, and urban growth in China, coastal expansion in Spain, right? As you can see the dramatic changes during the past 2 decades of the shoreline retreat. And again, urban expansion in Mexico, see how quickly those coastal communities expand along the coastline. Besides those traditional optical satellite imagery, you can also have some other, for example, weather and climate data to create this kind of animation. So this animation shows you just one single day, 24 hours, right? And you can create animation like this. Again, no coding, just goes to the web app. You'll be able to create like this and download it. So the last one I'm going to show you is the vegetation dynamics, right? So this one shows you in Africa. I think Senegal is somewhere here, right, on the between the desert and the vegetation. So this shows you longer, like the data aggregated from a couple of decades, and then you can aggregate data to show the long-term changes, right? So you see the season, the vegetation, the phenology changing from spring to summer to fall and then to winter. So you can see the dynamics. So again, no coding, then you can create something like this very easily using the web app that I showed you earlier. Okay, so those are some examples. And next, I'm going to show you, introduce those packages behind the scene, like what kind of packages or tools or platforms were used to create those kind of animations. So the first one is called Geospatial. It's actually quite easy to remember. And this is the latest one that I developed, I think maybe a month or two ago. And so for those of you with some coding background or Python, you might probably have encountered, right? If you're trying to install some packages and to do some spatial analysis, you need to create the environment, you need to install one package, and then later you might need to install some additional packages. But it's always a pain because sometimes they have some packages, they have conflict. When you try to install that, the environment does not allow you. So the purpose of this geospatial package is to actually create a package that install all the commonly used packages, just using one command line. So in that way, you don't have to try to deal with the dependency conflict or Windows, Linux, or Mac. So it's always a hassle to trying to do that. And it includes most of the commonly used one, and then you can use on Google Colab or Baidu or any other Python or cloud computing environment that support Python. So on the right here, show you the video. If you're interested in, you can watch the video how to install and how to. If you can also recommend. I think there are a lot of packages right now included, but you're welcome to support more. And so as I mentioned earlier, my goal is to make things easier for other people to use. So in this case, you can use that with Google Colab. So for those of you who are not familiar with Colab, it's actually a cloud computing environment provided by Google. It's free, so everyone you can use. If you have a Gmail account, you can actually run computation. So you don't actually have to have a good computer in order to do geospatial analysis. You just need a browser, and you can do it on your iPad. You can do it on your cell phone. It's not much barrier. So all you need to do, for example, here, you just need to first install the package, and then you can do in mapping. For example, using Leafmap, you can load the Leafmap. I will talk a lot more about Leafmap later, how you can use that. But for right here, shows you the output, right? You can see the map and everything's interactive. You can zoom in, you can zoom out, you can pan the map. So again, you can click the link here to go to the Colab, and then you can start executing the source code. So very easy to do. And so that's basically the goal. The package itself doesn't do anything. It just basically install a bunch of packages for geospatial analysis. So next, I'm going to talk about Gmap. But before I do that, I am going to briefly introduce Google Earth Engine. I'm not sure how many of you have used that. So Google Earth Engine is different from Google Earth, right? So think about Google Earth. Probably many of you have used that Google Map, Google Earth, right? You can actually visualize the data, you can see the imagery, but you cannot use it for any analysis. So basically, it's just a viewer. If you're trying to analyze, for example, ask some simple questions, for example, what's the percentage of urban area? How big is the water? How big is the lake? Google Earth won't be able to tell you because you cannot do analysis. On the other hand, Earth Engine basically is the compute engine behind Google Earth. So some of the imagery that you see on Google Earth might be processed or produced by actually using Google Earth Engine. So it's free for research and education and non-profit, but you need to sign up for an account and then you can start using that. So here I'm going to give you an analogy that if you have never used Google Earth Engine, why do we want it? Why do we need Google Earth Engine or other cloud computing platform? So here the analogy is like a movie. When in the past, like if you watch a movie, you might need to buy the DVD. You need to have a computer that has the DVD ROM that you can read the DVD or Blu-ray, and then you can play. But nowadays, I think really people buy DVD anymore, right? You just subscribe to some of those streaming services, Netflix or Amazon Prime or Disney Plus or any other whatever streaming services in your country, and then you can just watch the movie using any browser on your computer, on your cell phone, or on your tablet, right? You don't have to actually have a good computer actually do that. And you don't have to worry about storage, right? You don't need to have a big hard drive actually to watch a movie because everything is online streaming. And it's the same idea as the traditional desktop computing, GS or remote sensing on traditional desktop compared to Google Earth Engine or any other cloud computing platform. So basically you can streaming the data and you can do computation in real time, so that you don't have to worry about downloading the data. You don't need to have a very high speed internet. You can still do a lot of analysis. So Google's engine is very powerful, and one of the common application is, for example, removing the cloud or create the so-called cloud-free imagery. So let me give you an example, right? So for example, Landsat or any other satellite sensors, they acquire data every couple of days, every couple of weeks, and then during every year you get a bunch of images, right? But it's very unlikely that you're going to get a cloud-free imagery just with totally free of cloud-free imagery just within one day. So just using Google's engine with a couple lines of code, you can convert a bunch of cloud images into a cloud-free, just like this, right? So if you see some of the images on Google Earth, you might see that, oh, those images are very nice. There's no cloud, but in reality, they might not be the original imagery because it might have been processed to create this kind of cloud-free. And again, it's very easy to use. If you try, you can try it out if you want. So one of the biggest advantage of Google's engine is that it has a huge data catalog. So right now it's over 50 petabyte, around more than 800 public data sets. So keep in mind here, like 800 looks a small number, but it's like every sensor. So for example, Landsat, like you have so many images, like millions of images, is considered as one data set. So Landsat, Sentinel, MODIS, land use, land cover, weather, climate, pretty much most of the data set, satellite data set in the public domain are available in Google's engine. So you can, as long as you, so each data set has a unique ID. So you can just reference the ID and then you can load the data set without having to download anything. So this makes it really easy if you want to analyze something at a global scale, because you don't have to download the data. You can just do the analysis on the fly. And so this is the so-called the code editor using the JavaScript. Of course, you need to learn some coding using the JavaScript, so you can sign up an account and you can log into, and then it allows you to, for example, write your source code. You can also visualize the results. There are also a bunch of things you can do here in the JavaScript code editor. But most of people probably the first language is probably not JavaScript. It might be Python or something else nowadays. So Google's engine actually provide three APIs, the REST API and then the JavaScript and Python APIs. And so there are some advantages and disadvantages of each API, but my focus has been on the Python API. But Google's engine does not have the functionality for visualization using the Python API. But the nice thing is that you have a lot more packages, and they're seeing here, you can share, you can do batch processing. You also have a lot of IDE. The JavaScript uses in the browser, it is limited debugging capability. So if you're really good, I think it's good to use. But if you're a beginner, you're trying to do the debugging, something goes wrong, then it might take you a long time to do that. And also here, for example, you can integrate it with open source. Yes, you can do deep learning. You can also have a communication with your computer. So that's the good thing about the Python API. Again, the JavaScript API, you are limited to the browser. It doesn't really have communication with your computer. So if you have any files you want to open, it doesn't allow you. So this diagram here shows you the difference, right? So the X is actually the JavaScript API, but those red crosses actually, so the Python API only has the computation. It doesn't really have the visualization functionality. But JavaScript has both. So, and that's why I developed the Gmap package actually to make it easy for you to visualize Google's engine data set. You can do computation. You can do a lot of things. Very, very similar to the JavaScript API, but you can also do a lot of things that JavaScript API cannot do. And so this is brings you to the Gmap. Again, it's open source. You can check out the link here. Go to the GitHub repository so you can take a look. And it has been quite popular in the Google's engine community, especially for Python user. You can see it has over 2,000 stars. So you're welcome to start there if you like. And so here, Gmap actually built on top of Google's engine. So the back end for computation is using Google's engine, but for visualization, use a lot of other Python packages, and they also allow you to visualize the data set interactively in a Jupyter environment. So it's a Python package. You can install just using pip. Again, I have a lot of video tutorials teaching you how to install and how to use that. You can check out the video if you like. And so as I mentioned earlier in the geospatial package, right, you can just click the link, open up in your browser, and then you can start doing coding. So this shows you some simple example, right? On Google Colab, you install the package, you import the libraries, you load the data set, and then you visualize, right? So think about the difference between Google Colab or Google Engine compared to traditionally what you do. For example, you want to look at a satellite imagery or Landsat. You need to go to the website to download the data. And then once you download the data, you might also need to make sure that you download the right data. If it's not correct, then you need to re-download and then open to your computer. Then you need to have GIS or remote sensing software, for example, ArcGIS or QGIS, and then open the data set and then visualize, right? It takes a whole longer. But now, just capitalize the code. As long as you know how to get that, you can visualize very easily. In Google Colab, just using a browser, you can also set it up. You can install the packages on your computer, and then you'll be able to actually visualize the data set very, very easily. And the documentation website is gmap.org. You can go to the website. There are tons of tutorials and documentation showing you how to install, how to get started. And again, if you have questions, you can post it on GitHub. So I also published a short paper describing the package in 2020. And you're welcome to cite the paper if you find it useful in your project or your publication. Next, I'm going to quickly show you some of the tutorials. So I have been publishing Google Earth Engine tutorial, other open source. So for example, just for Google Earth Engine, this tutorials series, I published over 60 videos. And so on average, each video roughly 16 minutes. Total length is almost 19 hours. So basically you can have maybe 1 or 2 days. If you really want to learn everything about Gmap, you can take a look. And so you're also welcome to subscribe to my channel. Right now, almost 40,000 subscribers and also 500,000 views, and I think over 20,000 watch hours. So basically a lot of people are interested in, you can click the link if you want to subscribe. So for each video or tutorials that I develop, right now, 113 tutorials. So this is just one example. I stop putting it on the PowerPoint, it just gets too many. So for each tutorial, you have a full video, usually 15 to 20 minutes, teaching you how to go through step by step. I also have a Jupyter notebook that you can download the notebook. You can run that through step by step, and you can execute it. And so you will be able to reproduce what I did exactly in the video. Also have a GF animation, basically a quick, maybe 20, 30 seconds animation showing you the highlight of each video. So again, welcome to check out the link here to see which video that you might find interesting, but you can also go through them, all of them. And so last year, 2021, I also presented a 90 minutes workshop at the GeoPython conference, give you a kind of a comprehensive introduction to Google Earth Engine and Gmap. So you're welcome to try it out. It gives you basically all the key features, what kind of things you can do with the Google Earth Engine Python API and the Gmap. So next, I'm going to quickly go through some of the key features, right? So my talk is not going to teach you how to do things step by step in very detail, but I'm going to give you a big picture or give you some impression of what kind of things you can do. So later, if you find some user cases, you can always come back to learn more how to do that individually. So you just quickly go through some of the things that you can do using Gmap. So for example, if you already know JavaScript, Python, Google Earth Engine JavaScript API, if you want to convert to Python, Gmap makes it easier. So just copy and paste the source code, and then in the Jupyter notebook, it's going to automatically convert your JavaScript source code to Python, and then you can directly load the data. So as you can see, that's just one copy and paste, click convert, and then run the source code, you get the data instantly. So this is very, very easy. So it's going to save you a lot of time if you need to do some conversion. as I mentioned earlier, Google's engine has over 60 petabyte, right? So 1 petabyte is like 1,000 terabytes. So 60,000 terabyte of data. So it's a huge data catalog. And you can just access the data set with just a couple lines code, even not coding, right? So you can, in Gmap, just type your keywords, and then you can click search, and then you'll be able to load the data set directly onto the map, just like opening a file. Pretty easy to do. And it can be any data set. It can be vector, it can be raster data set. You can also change the layer opacity. So for example, in traditional software, you can open a data set, you can change the opacity. This one is the same. So you can change the layer visualization interactively. You can also customize different band combination. And you can also inspect. So for example, you want to get a pixel value. Keep it in mind. So Google's engine is cloud computing. So it's different from traditional. For example, in ArcGIS or Envy, you open a data set, you click a mouse, you get the pixel values. Google's engine is different. Keep in mind, everything is in the cloud. So what this one is doing is actually when you click your mouse, it's going to get the coordinates, and then it's going to send the coordinates to Google's engine to compute, and then get the pixel values, and then return to you. So definitely you need to have internet, otherwise it won't work. And this gives you a quick way to actually, for example, get all the pixel values or the vector data. You want to get the attribute table, the columns of that specific polygon that you click. So very easy to use, no coding. You can also create some plot, for example, spectral signature. They say you want to look at the spectral signature of Landsat data, MODIS, whatever. Just click on your mouse, and then that's it. You can also do multi-spectral data. So for example, multi-spectral data might have like 200 bands, right? So once you click, you get all the pixel values, it's going to plot, and then you will see the plot very, very easily, right? So this is like, if you're just trying to do that by yourself, it takes you hundreds of lines of code, but now I makes it easier so that you don't have to do the coding. Besides using Google's engine dataset, those are in the cloud, you can also open dataset on a local computer. So this is not something the JavaScript API can do. In Python, you can just open the data. It can be a straight file, it can be a GeoJSON, it doesn't matter. And you just open, and then you can also convert the data layer directly to Google's engine dataset if you want. You can also open raster data. So basically any geospatial dataset on your local computer, Gmap can open, and then you can overlay on top of the Google's engine dataset to make it easy for you to do. And so earlier I mentioned you can change the layer opacity, but you can also change the color match. So for example, we have the DM, right? You can actually change the color without having to actually do any coding. So you can also have a color palette. You can have a legend. So it makes it really easy for you to actually visualize raster dataset just like desktop GIS, right? So you can, for example, single band or multi-spectral band, I can change the band combination very easily. Just select whatever band that you want, and then hit apply, right? You get the new visualization. And you can also visualize the vector data, right? So you open a vector data set, and then you can just use the user interface to change the visualization. So for example, you can change the color, you can change the outline. There are a lot of things you can do. So this one here, for example, right, you can change just to showing the outline to red, or you can change a lot of other stuff, right? So it makes it easy for you to customize the vector data to the way that you want it to be visualized. So try it out. And of course, you can do a lot of machine learning stuff. So you can, for example, do supervised classification or unsupervised or random forest decision tree. There are a lot of algorithm available. So if you need to do some like land use, land cover, you can do that. After you do the classification, you get the result. You might want to maybe visualize the changes. So in this case, for example, I want to visualize land cover change for the past a couple decades, 10, 20 years, for example, in Las Vegas, right? So this gives you a quick way to visualize. Again, here, you don't do any coding, but you can create this kind of a Sankey diagram without having to write any live code. So you can create it pretty easy, right? So different data set, different land cover data set at a global scale or in the US or any region, just simply draw a rectangle, and then you can create something like this pretty easily. And you can also, for example, have time series images that you can see the changes between different years. And also you can create some nice maps. So after you finish on all the analysis, you might want to export some of those graphs to put in your publication or your whatever project report, right? And so Gmap has a Kato EE module that allows you to create this kind of publication quality maps just within a couple of lines of code. So and the data actually from Google's engine, so you don't have to download any data, but you can create this kind of nice figures. And lastly, it's about publishing. So after you create the products, after you develop, you might want to make it accessible to other people. So you can develop an interactive web app, you can publish the map, you can create an app that allows users to interact, just like what I show you at the beginning of the presentation, right? The time-lapse web app allows you to actually create animations using the satellite data without coding. So those are things that you can do using all the open source packages. You can develop the interface behind the scene. You can use Google's engine or other cloud computing platforms. Okay, so there's a kind of brief introduction to Gmap, right, using Google's engine. And so the next one I'm going to introduce is called Leafmap. So Leafmap is kind of different from Gmap. So the reason that I developed the so-called Leafmap is that a lot of people have concern that Google's engine itself is not open source, although Gmap is open source, but the computing backend Google's engine is not. And a lot of people have concern that Google's engine might go away in the future. We don't know, but it's always good to have a backup or have a backup or have something that does not rely on something, because if Google's engine is gone, Gmap will not be useful at all. So I developed Leafmap that can be used in any cloud computing platforms and does not rely on anything. So it will last definitely longer because it does not rely on Google's engine. You can use it with Google's engine, but it's not a requirement. So, and you can use Leafmap can be used, for example, with Microsoft Planetary Computer or any other cloud computing environment, as long as it supports Python and Jupyter. So, and this one was developed in last year, I think a year ago, so May 2021, so just 1 year. And you can see it's also quite popular, 1,200 on GitHub. So again, you are welcome to check out the source code. Everything is open source. So if you're interested in learning the source code, you can check out GitHub. Also, I create video tutorials teach how to use it. So you're welcome to check out the videos. Again, it's just a Python package, so you can install and in Google Colab or any other cloud computing environments. Similarly, Leafmap has a website, leafmap.org, so you can check out the website. Also has very detailed documentation showing you how to use that, how to get started, how to check the function, how to search. You can also a lot about tutorials. Similarly, there's a short paper describing the package, so you can cite this one if you find it useful in your publication. And similarly, I'm going to show you some key features that's available for the Leafmap package. So for example, many of the things are similar between Gmap and Leafmap, but here I'm going to show you something that I'm not shown in the Gmap package, right? So for example, you can change the base map, just one click, and there are over, I think, 200 base map allows you to choose from. So you can just simply click and then you can change without having to download anything. So basically no coding. Once you create a map, you will be able to change the base map pretty easy. So there are a lot of those that are available for your selection. You can also do, not sure why there's a red cross here on my screen. Anyway, so you can also, for example, use the time slider. So the time slider allows you to visualize time series images. So for example, just if you have, for example, 10, 20 images, you just click the button, and then here it allows you to visualize, for example, planning imagery. And then you can pause, you can play. So you can basically visualize the time series images without coding. And you can also open data set, like the data set can be something stored on your local computer, or it can be something online. So you can pretty easily make it pretty open the data easily without having to write any line of code. So so it can be vector data, it can be raster data, it can be polygon, polyline, whatever, no coding. And so sometimes you might have some point data set, for example, GPS coordinates, X, Y coordinates, and you want to add the data onto the map. So Gmap, Leafmap also makes it really easy. There's just a couple lines, and you can click, you can open the data, and it goes show some like pop up. So everything is interactive, just like you in a traditional GIS. You can open those data sets. You can also download vector data, for example, OpenStreetMap, right? And just 1 or 2 lines, you can download the data just for your region. For example, it can be buildings, it can be any point of inches, roads, network, street, whatever. Anything within the open source OpenStreetMap database, you can download it and then directly display it on the map without writing many lines of code. For example, water, lakes, something like that. So makes it really easy for you to get data. Even if you don't know where to get, OpenStreetMap will always be a good option to try it out. If you're familiar with a database, so for example, PostGIS database, Leafmap can also read the database data from the database and then plot that on the map interactive. So makes the data interactive without having to download the data, export the data, and then open in GS, desktop GS. And the next one is split panel map, right? So sometimes if you have multiple imagery, you want to see the changes, you want to be able to use the slide, for example, left and right, so you can compare 2 different data sources very easy. For example, this is land use, land cover change for NLCD, National Land Cover Database. You can do that pretty easily. So lots of applications. And besides the split panel map, you can also have multiple maps. So for example, if you move one map, it's going to automatically update the other map. So also very useful. You can also have multiple maps together. So in this case, you have 4 maps, and you can move one map, it's going to update the other one. So useful for visualization. And similarly, if you have some other data set, so in this case, it's like a population, right? So it's the same data set, but if you use different classification schemes, you are going to get different results. So Leafmap has different built on top of the map classify package that allows you to visualize data set very easily, just 1 line of code, and then you can customize how you want the map to look like using your preferred classification schemes. Leafmap also has Whitebox. So Whitebox is an open source Python package for doing geospatial analysis. It built on top of the WhiteboxTools that developed by Dr. John Lindsay in Canada. It has over 500 tools, just like ArcGIS Toolbox. But if you use ArcGIS Toolbox, you need to install the ArcGIS. It's a huge package. But for this one, it's open source, and you have all the tools directly within the map interface. Basically, you can do everything just using a browser without installing anything on a computer. You can do analysis, you can load data, you can run analysis. So very powerful, over 500 tools. Definitely there's one tool that might be useful for you. So try that out. And lastly, a couple more about cloud computing. So if you have any data, for example, any imagery stored in the cloud, so-called cloud optimized GeoTIFF, or spatial temporal asset catalog. So those are basically cloud format that makes it easy for you to stream the data. And so Google Leafmap can actually open the data directly. So in this case, it's opening data from Microsoft Planetary Computer, load the data set directly onto the map without having to download anything. So this is kind of similar to the Google engine, right? You can load the data set, you can put it on the interactive map. But in this case, it's more general. It can be data hosted by Microsoft Planetary Computer, or it can also be any data set hosted online, as long as it is a cloud optimized GeoTIFF format or anywhere. As long as you have access to the data set, you can use Leafmap. And so the Microsoft Planetary Computer has a huge data catalog. So it's also several petabytes of data. And so Leafmap allows you to source the data set. You can simply, for example, draw a rectangle and then specify the date and where you want to get the data. And you'll be able to automatically load the data directly to your computer. Again, you don't have to download data. Leafmap, we retrieve the data and then display that on the map, so you can see basically the data catalog. So you can also try it out. If you want the data to be within a specific time range, you can specify the time. So basically, you can search the data catalog by area or by date. For example, in this case, Sentinel-2 imagery, right? And then you can be able to download data and then show the data without having to actually download this source data to your computer. I believe this is the last one. So similar to what I show you in Gmap, that you can click your mouse on the image, and then you can get the pixel values, and then you can retrieve the pixel values. So you can do something very similar in Leafmap. Once you load the data set from Plenty to the computer, you can actually query the data, query the pixel values interactively on the fly. So the data is not on your computer, it's in the cloud. So if you want to see, okay, what's the pixel value, Leafmap can do it for you. You can also extract the pixel value. So when you click on mouse, it's going to get the pixel values, and then it's going to save that to a CSV. So you can download it to your computer, and then you can also actually reopen the data set, right? So in this case, I can reopen the data set where I click, right? So basically, this can be useful if you need to collect training samples. If you need to do image classification, you want to collect the training samples so they can input into your model, then you can use Leafmap actually to collect the training samples. All right, so that's kind of a brief introduction to some of the key features of Leafmap and Gmap. Again, it's just a small section of the features. You are welcome to check out the website gmap.org or leafmap.org. And there are a lot more tutorials online, and you can try it out. And just to give you some big picture of what kind of things you can do. And so next, I'm going to show you some additional resources. If you're interested in learning more, you want to get started, or you are interested in finding out more resources, you can also try out the other GitHub repo that I developed. It's called Awesome G. So it has a lot of other G resources. So you can try it out, for example, publications, papers, tutorials, workshops, or something like that. So, and I also published some of the tutorials on YouTube. Some of the courses that I taught last year, because of the pandemic, so it's all online courses, and I put all the for my that I taught at my university, but I also make the videos online, so you can check that out. The first one is called Geographic Software Design. This course teaches you how to develop open source packages and how to contribute to open source packages and how to develop a package, for example, like Gmap. So you introduce all the tools and also a lot of practical examples, 18 hours. So you can, if you want to basically contribute to the open source community, this might be useful for you. There are another course called Spatial Data Management that I taught using Google Sensing, 20 hours, 20 videos, 10 hours. So give you all kind of basics about Google Sensing and the Python API and Gmap, so you can understand how to get the data, how to source the data, how to load the data, and how to analyze the data. So the last one is about database, so PostGIS. So if you're interested in learning how to store the data in GIS Post database or how to get the data out, this course might be useful for you. And thank you very much for your attention. And that's all for my presentation. You're welcome to follow me on Twitter or LinkedIn, or if you have any questions, you can email me or you can ask questions on the GitHub. So if you're interested question about Gmap, you go to the Gmap GitHub repository. So there's a discussion board that everyone can ask questions. So all my GitHub open source projects, there's a discussion board that allow anyone to ask questions, and I try my best to answer questions. And that's all. Thank you very much. I'm happy to answer any questions that you might have.
Thank you, Dr. Qisheng. about your presentation. You have shown main application throughout this presentation. You have shown the many application of geospatial data by using Python. You have shown machine learning platforms such as Google Earth Engine, but also platform and many package such as Leafmap in processing and visualization, vector and data, raster data. And I think that it's very important for the participant to know today the importance and the opportunities we have to develop geospatial data on many platforms with machine learning. And everyone have now internet, and you have the opportunities to go more about the classic software. Now we have just 15 minutes to questions. If someone have question, or if he want to have to contributions, you have the flow. Yes, you can turn on your mic, or if you want, you can, I think, yes, you can turn off your mic, or you can read also your question or your contributions. Thank you very much, Dr. Wu, for your presentation.
You're welcome. So you're welcome to ask questions if you have any. I'm happy to answer your questions.
Okay. Okay, Brahima Keita, you have the floor. Vous avez la parole. Just let me to translate some for the people who don't we are in French regions. On a juste essayé aujourd'hui de présenter les applications nombreuses qu'on peut avoir de Python avec les données géospatiales. Aujourd'hui, comment est-ce que à travers le machine learning, on peut arriver à faire de la cartographie du SIG sur des plateformes qui sont aujourd'hui en ligne. Il a essayé de rappeler des plateformes de Google Earth Engine, mais aussi des plateformes qui ne sont pas forcément propriétaires. Il appelle également des plateformes open source. Mais le plus important, c'est toute la documentation aujourd'hui gratuite que nous avons sur Internet aujourd'hui, qui nous permet de pouvoir nous documenter, mais également de nous former sur beaucoup de choses qui aujourd'hui donnent une nouvelle donne à la dimension géospatiale. On est dans un monde de bouleversement, on passe des données en local avec des systèmes classiques, aujourd'hui vers tout ce qui est dans le cloud, quoi, dans les nuages ou dans les machine learning. Donc c'est une invite également qu'on fait à beaucoup qui sont dans le spatial d'ouvrir les yeux et d'explorer ce nouveau monde qui s'offre à nous. Donc la parole maintenant est à qui veut la prendre. Il y a Brahima Keita. You have the floor for the question or contribution. Brahima Keita. Vous pouvez activer votre micro, s'il vous plaît.
Yeah. Thank you, Dr. Wu, and thank you, Dr. Labaly, for the presentation. My question is about the differences between Gmap and the second one, Leafmap. Is it worth it to learn Gmap or Leafmap? But because I feel like Gmap and Leafmap are the same.
They are not the same. So Gmap is specific for Google Engine, and Leafmap is more general. So you can use it with Microsoft printed to the computer or any other. So you can do any internet mapping. Because Gmap, you need to have an account. Otherwise, basically, it doesn't work. You need to have a Google Engine account, and it has a lot of functions for you to basically design to deal with Google Engine. But if you're already familiar with Gmap, Gmap is very easy because the interface is very similar, the functions are very similar, but it doesn't have the limit that you have to use Google Engine, and you have a lot more flexibility. And so, but Gmap is just for Google Engine. It won't work for other really. Basically, Gmap connects to Google Engine, all the computing power provided by Google Engine. Gmap actually doesn't have that. So you can use that in any other cloud computing platform that has the computing power. You can load data sets. So right now, most of functionality in Leafmap is a lot more advanced compared to Gmap. So kind of Gmap right now is not the top priority, but it's still, because a lot of people use that, I still maintain and develop. But again, if you want to look for the new features, most likely it will appear in Leafmap first. And then, so if it can also be used in Leafmap, then I will try to put over some of those into Gmap.
Okay, thank you.
Yeah, thank you for your answer. And my concern was about a beginner, for example, for someone who want to begin like open data.
Yeah, then just use Leafmap. You don't need Google anything. You just use Leafmap. You can open data on a computer. You can open data from the internet, and you don't have a hassle to apply for Google's Engine account, because I know some people having difficulty to get the Google's Engine account approved, and Leafmap is basically a lot easier to start.
Okay, thank you.
Thank you. Norman Avila, if you can turn on your mic.
Yes, hello. Thank you, Dr. Wu, for your great presentation. I just want to recall what will be the workflow, or if it's possible, to once you have prepared the data or the maps or the information that you want on any platform, G or with Leaflet, if you want to deploy like an application where any user can check the data and generate their information as you've shown, you have to use a hosting or Flask, or what's the workflow for this to be able, or is just for analysis inside a Colab or a Jupyter notebook?
So that's basically how to deploy the web app. And so for now, I primarily use a package called Streamlit. So let me send the link here in the chat box. Just like I mentioned earlier in the beginning, right? I developed a web app that allows you to create time-lapse animation without having to actually have something. So Streamlit allows you to host. Let me also send the website. It's an open source Python package that allows you to build interactive web app. It's free, and it has unlimited hosting. So you can create unlimited web apps. And you can see for the first link, behind the scene is actually using Google's Engine and Gmap. You can do computation, so allows you to do that. So this is one way. The other way is using just Jupyter Notebook. So there's a package called Voila. You can also check out my Gmap tutorials. I think I have a couple of tutorials teach you how to develop web app using Voila, basically turning your Jupyter Notebook into a web application. So when user go to it basically just deploy the notebook. You don't have to make any changes. It's just a Jupyter Notebook. So when it executes, it turns into a website, and then user can actually play with that. So that's the second way that you can do. I think, let me see here, Gmap tutorials.
And if it's your own data, that using Leafmap will be the same process with this kind of...
Yeah, pretty much the same. So the data, if it's on the hosting server or it's somewhere else, Leafmap can read the data from the cloud, or you can read data from your local computer, and then you'll be able to actually to do that. So if you look at, let me see here, 20 tutorials, 26 to 28. I send the link in there, so you can actually take a look at how I develop. So you can. The nice thing about Streamlit is that you don't have to have hosting. You don't have to have a server to hosting. You don't need to pay anything. But for Voila and Jupyter Notebook or others, you do need to have a server. So those are kind of, you can, for example, some free computing sources just like Heroku, you can deploy. It's free, but it's not unlimited. So that's the downside. If you have a server, then you can actually use a server to host the web app, so the others can interact with your web app, and you can also access the data on your local computer.
Thank you, Dr. Wu. Thank you for your links and reference.
Thank you. And Dr. Wu, have some question on the question from Basiru Jao. What is the scale of exploitation of Google Earth Engine? The question for Basiru Jao. Do you hear it? Do you see it? Yes.
I don't quite understand the question. Exploration. What does that mean?
Yes, Basiru Jao, or you have also
the scale of exportation. So basically, if you want to export the data, it's up to you. You can specify the resolution. So for example, Landsat is 30 meters. You can specify 30 meters to export the data. So it's up to you. So the smaller the number, the more fine detail, the longer it's going to take for you to download the data. So my recommendation would be try to avoid export data from Google's engine, like images, vector. It's going to be very slow. So it's always a good practice to do all the computation within Google's engine finish and then just get some result, get some summarized statistics or get some cost resolution, because export data is a free platform. Everyone need to basically wait in line to get the data. So if you're trying to export hundreds of gigabytes, it's going to take a while. So it's not a good, really a good solution. And so if you're just trying to calculate some number, for example, the area, the percentage is going to be pretty quick. And this what Google SEIN is well suited for. It's not really a downloading platform. You can filter the data, you can run some analysis, you can develop the algorithm, get some results. And then if you really have to export, then export. Otherwise, don't try to export several terabytes data from Google SEIN. It's not going to work. It's going to take you months, weeks to actually export the data.
Yes, thank you. Jibril, you have the Jibril, yes, Jibril. Can you turn on your mic, please, for your question or contribution?
Okay. Hello, dear participant. I am Jibriru Daudaba, teacher, researcher, and trainer at the Faculty of Science and Technology of Education and Training of Dakar. First of all, I want to tell all my congratulations to Dr. Wu and to our colleague, Dr. Labaly Toure, for all his efforts to promote space science in Senegal and in developing countries in general. Now, I would like to ask 2 or 3 questions. The first, is there a Python version to educate children and for school use? Second,
go ahead.
Can I continue?
Yes, yes, you can continue. Yes, after you, the two will respond. Yes.
Okay. The second question is, how do you think Python and space science can contribute to education for sustainable development and climate change? And the last question is like a contribution, because I appreciate very well certain efforts to make a link between higher education and school geography. The example of in class in CART by Labaly and Geomatica is here. But are there really initiatives to better introduce from an early age for a better spatial awareness of citizens? Okay, here are my questions.
Okay, so so the first question is about the you mean the Google SEIN for school use, using schools?
Yes, for school use and for kites.
Yes.
Yeah, it's free.
Children,
It's free for resource education and non-profit, but not for commercial. If you for commercial, they need to apply for a license. So you're welcome to use it. Google SEIN is free. Microsoft Planetary is also free. So you're welcome to, but you need to apply for an account, and then once it's approved, you can use it. And so definitely it can be used in school, high school or university settings. And I've been teaching here. So student, if you have a EDU email account, you can apply usually instant, I think, approval. But if you have some Gmail personal, you might need to wait for a couple of days before it can be approved. So yes, the answer is yes, you can use that for school and teaching.
Okay.
And the second question is about the contribution to sustainable development.
climate change.
Yeah, of course, you satellite data are very one of the key resources that we use to monitor the environment and also contribute to decision making. So the more people are using satellite data, the more people are using geospatial technologies, the more people are aware what is going on in our environment. And just show you the example earlier, some of the animations that I saw at the beginning of the presentation, right? So those are things that some of the things that are not sustainable. So if people see that, they realize that, okay, something is wrong. We are damaging the environment, then people need to protect. So that might, for example, if you show some of those things to the stakeholders of government officials, they might be able to understand that. Otherwise, people need to, in your mind, need to realize, okay, what is going on. But if you have some set of images to show them, it definitely can contribute to sustainable development, that people have a better understanding what's going on and take actions. For example, deforestation, wildfire, coastal erosion, something like that, right? Unless you have some proof, people might not understand what is going on. So, what's the last question? I forgot.
Yes, and just in Senegal, we since 4 years we tried to promote geospatial on kids on schools, for elementary schools, and we see the in one class one map to see how we can promote geospatial data on schools for kids. And he's about, do you have a link or material for Python for children? Is it material for this?
Yeah, for general Python, there are lots of things on YouTube. I believe there will be some YouTube videos for like Python for kids. I would not like surprised that definitely there will be something in there.
Yes.
And you check out YouTube. Definitely I seen this out there. A lot of kids right now are learning programming at their early years. And for geospatial, of course you can welcome check out my YouTube video for Leafmap and Gmap and others. And there are also other video. For example, Microsoft also has some very good tutorials for just teaching Python. And for geospatial, there are some online courses you can take, or some on YouTube videos are free. But for me, if you really want to get good at geospatial, just look at some of the popular open source Python packages and then go to their GitHub repository. And there will always be example and tutorials. Just follow the example, download the notebook and then run and go through. You will learn much better. You can also look at the source code. For example, GeoPandas, Raster.io, or Gmap, Leafmap. There are so many things you can learn. If you want to learn, there are a lot of things you won't have enough time to learn. Just for me, there are so many things coming out every day and new things. And sometimes I won't be able to actually learn all of them, but at least you know where to go. But GitHub definitely is my top choice if you want to learn something about geospatial, especially in terms of coding, because there are so many notebooks, examples, tutorials online. And if you have any question, you can submit an issue, open an issue, people will be able to help you out. So definitely there's something you should, and you eventually can contribute to GitHub. And that's the point of open source, that you benefit from the community, but you can also contribute to the community if you have questions or you find a bug or anything. So yeah, and probably GitHub is not really suitable for kids in elementary school or maybe high school. I think it may be possible, but people always can make things more accessible. And then, for example, those time-lapse animation I show you, it can definitely be shown to kids. They will be able to understand, right? But for high school or university, you might need not just on the phenomenon, you can actually do some analysis. For example, you see the ROC is shrinking, right? How fast, how many acres that we lost every year, and what's the speed? Or for example, coastal erosion, right? But you see the images, just the visual impression, but it's not something really quantitative analysis of the things. So if you know how to do that, you can also do it. Yeah.
Yes, thank you. And the last question is a deep learning model improved because many buildings do not marry the exact shape corresponding to reality by superimposing images from satellites or drones?
Yeah, so that data set is from Microsoft. So it's open source, it's free, and they created that one based on the imagery in Bing Maps. And so again, the location, the footprint might not exactly match the satellite imagery, because satellite imagery sometimes have some object or geolocation errors. So it's quite common that the building footprint does not align well with the imagery, because you don't know what imagery they use actually to delineate. So because there's multiple images, and the one you saw, for example, using Google or using other vendors, the imagery might not always the same. So until they release the original imagery that they use, and definitely I think it should overlap based on the algorithm that they described, but the algorithm is not open source. So you until they open source, also open source the data set, then people can actually reproduce. For now, you just have to use whatever they provide. And if it doesn't align with your data set, you can do some georeferencing to make the building footprint align well with the data set. But don't expect those kind of things at a global scale to be perfect. It aligns well in some locations. It might not do very well in other locations because just using artificial intelligence is not going to be, it's not going to do better than human beings. It's faster, but it's not going to be perfect in every scenario. So you just need to be careful when you use the data set. But it's still a good resource for countries that without that kind of data set. It's just a polygon, it doesn't have anything, but still, at least you know where the buildings are. That's it. How many buildings? What's the total area of buildings? Right? Those are some of the simple questions that you can address. We can just do whatever what we have, but it's not going to be perfect that meet all the criteria. And some countries might not have data, some have better quality, some like relatively poor quality, and it's normal. At least they make it available. That's the point.
Yes, thank you very much. It's 5:10, and I think that we have do 1 hour to the webinar. I don't see if there are a question, but I don't see a hand raised. I think that we can now go to finish this webinar. But before, I want to thank you very much, Dr. Kiyu, for your availability and for your sense to share. And I think that we have very appreciate and very learn about the application of geospatial with Pythons. And is a conference we organize sometimes with the University of Saloum to develop the connection between people we are working on geospatial data and or on Python or on informatics. And it's an opportunity to us to have a link and to share everyone, depending of your country, of your university. But we think that it can be good to have this connection to share knowledge, and it's very important. And thank you very much. And I very thanks for the participant. And before we close, I just want to everyone to turn on your camera to have a picture, a virtual picture of the participant, please. And I will share after the presentation and the recording video to all the participants. And I invite you just after to send me your email to send me your email, and I will share you the document and the materials for application. Let me just take a picture, everyone. Yes, yes, we can just turn on your mic, please. Yes, it can be good, I think. Okay. Okay. Okay, second. Okay, last. Yes, just last. Okay. Thank you, everybody. Thank you, Dr. Kyusheng. I'm very happy for this webinar, and I give you for the network for the next meeting. Thank you very much.
Thank you. Take care, everyone. Bye-bye.
Bye-bye. Goodbye. Thank you. Thank you.
Thank you.